knew that the bio was said in public, I would make a different one. That looked too serious for me. Anyway, this question has already been done, but I want to ask you again. How many were at the climate strike today? Yes. Yes. You know, sometimes when I went to the climate strike, I thought there is so much emphasis on reducing the emission and reducing the carbon footprint that we apply. But the problem is that the emphasis is on the emissions that are coming from cars, for example, from the flights. But there is not so much emphasis now on the materials that we're using. I saw like a couple of signs that were talking about plastics. But I want to make plastics an issue again, and I hope I will be successful tonight. So just imagine an everyday life. You're going, for example, to make some shopping at a grocery store, and then the cashier arrives and tells you, you know, we have this plastic bag for you, and you say, I don't have it, I have to get it, I guess, so another plastic bag. And your house is full of plastic bags that you're used and reused, and what do you do then? Then you put them in the garbage, right? It's a lot of plastic that has been wasted. Then when you get home, you arrive and just use your smartphone. But when you use your smartphone, actually you don't realize that the screen of that smartphone was made of a very complicated ceramic material that is found, those materials are found only in Africa and very, very rare. So how can we solve these problems? These materials are difficult to make, they take a lot of energy to be made, and sometimes they're even rare. So the solution is always in the nature. If we use trees, we can actually solve these problems. And I explain you why. So, you know the boxes that you normally use for to put like the wine inside that they give you at the liquor store? You would never use them as shopping bags, right? Because once you put too much stuff inside, they will break easily. And that's because the paper they're made of is made of a very crystalline resistant part of the cellulose, of the main component of paper and woods, but also a very weak part, a part that is very disordered, it's not very mechanically resistant. So what we're trying to do is to get rid of this weak part. You will get rid of the weak part of the paper, so that your bag, the bag that you're going to make, actually will only keep the strong resistant part of the paper. So now you will have a plastic bag, a paper bag that is as strong as a plastic bag. And these are made of cellulose nanocrystals. The other thing, now you're wondering, why was it talking about the smartphone? What is the connection with that? So basically, if you take these cellulose nanocrystals and you let them dry in air, they will self-assemble in an helix, exactly like the DNA. And when a ray of light is hitting the cellulose nanocrystals, this kind of structure, it will reflect a specific color depending on how stretched or compressed the helix is. So it will reflect different colors, exactly like the liquid crystal devices. So once we will be able actually to use these cellulose nanocrystals to replace the screen of our smartphones, then when you want to replace the smartphone, for example, you will just go to the compost bin and leave your smartphone in the compost bin and get a new one, whatever you want. It will be super easy. So if you like this idea, please support cellulose nanocrystals and support me in this research. Thank you.